So the physics problem was to find the value of these spring scales as I hold it up in this position like that with a 1 kilogram mass. Okay, so here's how we do that. Put down my force scales. There are 3 forces acting on the mass, and the mass is at equilibrium. At equilibrium, the net force has to add up to 0, and we can break that into an x and a y direction. So in the x direction, I have F2 pulling that way, and a component of F1 pulling this way. I guess I should show that. This is the x component of that force. It's the opposite side, so we use sine of theta. Be very careful. X is not always cosine. It depends on how you draw it. Okay, so I have F2 minus F1 sine theta is equal to 0. I could find F2, but I don't know F1. Okay, in the y direction, I'm going to use the adjacent side to find the y component of F1. So I have F1 cosine theta minus mg is equal to 0, and I can solve for F1. I get 13.9 newtons. Then I plug that back in up here. I get 9.7. Is that what you got? Hopefully you did. Let's test it. Both my scales are on. That one needs to be zeroed. I'm going to hold that one right there. That one's zeroed. I'm going to put this one right here. And then we can put them just like we have right there. I'm going to line up the strings. And I get 9.6 and 13.1. So not exactly the same, but you know, it's pretty darn close, right? Just for a rough experiment like that. So did you get the problem right? Grade your own paper, mark your grade, and then put it in the grade book or something, but I'll see you later.